Hello, good evening, welcome back. Welcome back to the lab, welcome back to this series on the Erica Synths EDU DIY modules designed by Moritz Klein and built for your pleasure or entertainment right here in the Molten modular shed. Today we are soldering the Dual VCA. We got the Dual VCA almost built yesterday. Almost, but not entirely, but I have finished it off now, so we'll have a quick test of this in a moment, just so you can see that it's working. But before that, I just wanted to say hi, you're very welcome to kick your shoes off, get a cup of coffee, sit down and see how we go. It shouldn't be quite so long tonight. It's 3 hours yesterday, that was plenty. My brain was gone by that point, but I think we got somewhere. There was a lot of heavy stuff in amplifiers, in controlling volume, and it was quite a lot to wade through, but you know, I think for the most part I've learnt about the use of transistors. I've learnt about the pulling away through an emitter resistor, how you're essentially got this curve, this outrageous curve that you're trying to find a flat bit off. So you're kind of zooming in and pulling in to get a smaller refined area that will produce this potential volume change for you. There's lots of things about drift, about how to use negative feedback in order to compensate for changes in voltage and changes in different sorts of transistors. And then you had something else I don't call, oh yeah, an inversion, so that you ended up with two signals that were put together, that one of which was inverted, so that the offset was removed and so that it was perfectly on zero. Sort of genius really. And ultimately we got to control volume, which is what we were trying to do, and do that via voltage, via control voltage, which is not quite what we got to, but I've got there now, and we'll kick this off by demonstrating that, I think. To answer Matt's question, which I was about to type in, and then I thought, well, why don't we just start the video and do that? To answer Matt's question about what the next module is, Erica have just announced the case. So the next thing we'll be doing is the case and power supply, which is very exciting, which means we can then put the modules in an actual Erica Synths case. That's going to be great. So that's coming out in a couple of weeks. I think it's going to be available by the end of the month, so we should be able to do something straight in March on the case, and then we'll start to have it'll feel like we've got a proper system that we're building. So that's very exciting. So there we are. Good evening to people, to Tom, hi, Matt, Ken, Ian, hi, good to see you. Excuse me, just finished my coffee. Cryptech, Magic Forest, nice. My voice is a bit quiet. Is it a bit 1 2 1 2? Could be. Difficult to say. It's because I'm turned away at the camera and my microphone is over here on the desk. So when I turn back this way, hopefully it will be louder, with a bit of luck. There's only so much I can do with that. You'll just have to turn yourself up a little bit, and hopefully I won't blow you away with the sound coming from the oscillator and stuff. So good, here we are. So this evening we are going to start soldering. I haven't quite turned all that bit on yet because I want to just demo the VCA on the breadboard, which is the point that we got to yesterday. Yeah, so that's going to be what we're going to do first off. So I need to do a bit of jiggery pokery. Right, now this is interesting. Well, it's vaguely interesting. I found a new button, right? Because I'm forever evolving as a filmmaker, as a broadcaster. You know, I've got my team of people over there who have no idea what they're doing and who also don't exist. So it's just down to me. So what have I discovered? Well, this button down here, right, called merge, which is very exciting. But it does do something. It slightly highlights the fact that the arrangement of windows in this bit that you're looking at, that I'm pointing to over there on my computer that you can't see, it highlights the fact that they're slightly different. But what I can do is this, right, ready? Are you ready? See, I'm so enormously pleased with that. That was amazing. And then I can go back. Just wow. I had no idea it could do that. It's very exciting. I'm sorry, I'm very unprofessional being excited by such things. So there we go. So here we have the view of the breadboard. Let's get this bit out of the way for the start. And hopefully, oh, I've just pulled that out. Look, oh no, I've ruined everything. So we were looking at the final breadboard layout, which added voltage control and an output signal as opposed to just an input and then measuring it on the on the oscilloscope. Let's get this in the right place. There. That doesn't look remotely right. Oh, those two bits aren't connected. How is that bit connected then? Oh right, I'm well out. I need to be over here. That bit into there. That bit in there. When you start putting cables in, it all gets a little bit unstable. What I should probably do at some point is get some patch sockets, because these come up a lot, and I could like solder proper legs on and then plumb them in a bit better. Maybe that would be a good thing. I don't know. I have no idea. Probably not going to need the scope. Just get that out of the way. So let's center this a little bit more. Okay, see that all right? So what we had to do, we already had the input that we were running through various things. Come on, behave. Which was then going through the transistors in here. Yeah, so the transistors in here, lots of jiggery pokery going on. This over here was setting the amount of control voltage going in, or the amount of voltage in the system, I suppose, which was controlling ultimately the volume. We've now got this, which is the output here, signal coming out of the op amp ultimately, and out of that, those 2 volt. What was it? Yeah, the op amp with a negative thing on it in order to do something that I can't remember. And then down here we've got a CV input. So these are the different. This is an entire VCA voltage controlled amplifier in one go. So let's plug the red lines in, and let's see if we can make a sound before moving on to the soldering. You hearing that all right? So what I've got coming from over on this side, if you can see this a little bit in shot, I've got the Erica Synths VCO. That fella making a noise going in here. I've then got the output going just to the output so you can hear it, and then I've got the black modulator here just as an LFO going in. So that's taking an LFO into here, and that's controlling the volume. I think if I turn the knob here, something may or may not happen. It sort of makes it more or less fierce, if you see what I mean. Let me turn this down a little bit. So that seems to soften it a bit so you have more attack. Going the other way, it's a little bit more bang on the money. Does that make sense? Like so. Oh. So that buzz, yep, or what? What? Did you hear that or not? Tell me if you didn't hear it and I can do it all over again. But in the meantime, there you have it. There's the working VCA. I'll give you 20 seconds to say if you need to hear it again. Otherwise, we will pull this apart and we will get on with the soldering. What do you think? Good enough? Everyone's gone completely quiet. That's all right. Ow, that's all right. So let's have a look at what it says about the soldering side of things. So the manual at this point goes into all sorts of basics about resistance, current, voltage, lots of great stuff in here. It also tells you about the batteries and how everything was going. Yep, says Ken, sounds like a working VCA. Great, good. I'll unplug the batteries then and we can no longer worry about it. Excellent. So yeah, if you've been following it so far, do go through the rest of the manual because there's lots of very, very helpful and enlightening information in there. Get that out of the way. Give myself a little bit of room. So I will take away this bit so that I'll need that later when we're testing. Testing! That's always a fun time. But for the moment I need access to my soldering iron in my tiny little space. Without burning things. I've moved moved a couple of things around to try to free up enough space for things. Don't need that really, I just need this bit. That's the soldering iron. That bit there. Take these off. This is live telly, this is what this is. Use those later. I need the pen for the minute. Right, good, good. Right, what's that? Is that a cable that's going to get in the way of things? Yes, of course it is. Let's get that out of the way. Put that in there. Need a little bit of splash of water on my sponge. Just for cleaning the end of your soldering iron a little bit. Good. I'll turn it on. Just let that warm up while, what is this going to? All right, that's my microphone. So I'm going to need to just keep that under there. Don't melt it. Good, good. Bit of that. Lovely. Put that there. Great. Right, sorted. Are you comfortable? I think I'm getting comfortable. I have to remember what all these bits are on here. I can get rid of the patch wires for the moment. Now leaving them in there might help me remember what they are. It seems unlikely. I'm probably going to have to measure them again. Don't worry about it. So, PCB time then. Sorry, just trying to bend around just to ensure that the right thing is up on the screen. This is what we're looking at. Touching anything? No. Good, right, fine. So we're not going to do the front panel for a little bit. Let's get to the manual part where it talks about the build. So we go through all these bits about capacitors, diodes. It's all brilliant, totally brilliant. Tells you about all the components that are in the actual system and gives you better information about it than what we were able to do yesterday in the actual filming of it. Bipolar junction transistors. Yeah, it's all here. Look, graphs and everything. Then it talks about the tools you need to use. It talks about the oscilloscopes. Brilliant. Then the module assembly. Here we go. So before we start building, let's take a closer look. No, let's take a look at the complete schematic, which is on the next page. Oh, we probably need to look at this a little bit closer. So let me... Oh my goodness. I'm going to forget to use that button and then... Never mind, it doesn't really matter. So... we're going to look at the schematic that were used for the final module design and fabrication. You'll notice it was squeezed not just one but two VCAs into this module, while also adding a few components compared to the breadboard schematics. Most components on the production schematics have denominations, a name like R1, C1, VT1, VD1, etc., and values. Denominations help identify each component on the PCB, which is particularly useful during calibration, modification, or troubleshooting. So let's just have a look at this schematic. Yikes! So this is the thing we're going to need to look at. I can rotate this, can't I? Good. So as far as I can work out, on here we have two complete VCAs. So there's one at the top here, one at the bottom here. I wonder whether there's any normalization involved. Is that important? Does it even make any sense? Don't know. Well, we're going to treat them completely independently for the moment and then see what happens later on. So I'm going to zoom in on this one at the top just to see, is it possible for us to identify the different elements within this VCA from the schematic now that we've been through it? Although it was a whole 24 hours ago. So, woo, what does rotate your owl mean? Thanks, Ian. Just, you know, I can count on you to just slightly weird me out every time. So within this, let's have a look. So I can see my two transistors opposite each other, which creates the signal and the inverted signal. So that's right here in the middle, VT1 and VT2. Then that must be the emitter sink coming off both where the arrows is, because the arrow is the emitter, and that's the sink or sunk or something, drag coming down here, and that's where the CV control comes into force, because it's the changing of the voltage here which creates the negative feedback which changes the voltage at the base of the transistor. I think that's right. I think that's right. That's the negative feedback flow. So this bit is the CV, which when adjusted changes a wobbly voltage here, which changes the voltage here, which affects the voltage here, which is ultimately creating the output. Now at some point an input has to come in, so that has to come here at the base, I suppose. Didn't really look particularly closely at that, I didn't think. Anyway, so input comes in here. There's some shenanigans with inversion of the signal here in order to remove the offset, any DC offset that may have occurred, because you're putting together two opposite signals and the difference is removed. So that's cool. Something going on there that I don't quite remember. Something to do with smoothing it and scaling it, I think, which is what we ultimately do here with this op-amp. This produces a scaling to give us a larger output. So I think that is the nature of our VCA. Okay. I think that's it. I think we've grasped it. So let's go back to what was being said. So XS1 and 2XS6 are input and output jack sockets. Same we've been using on the breadboard. Yes, we use standard things for CV and audio. These sockets come with three lugs: a connector lug to which the tip of the patch cable is connected, and respectively audio or CV, a ground lug which connects the cable to ground, and a switching lug. Switching lug is normally connected to the connector lug, but as soon as you insert a patch cable into the socket it gets disconnected. This is very handy for grounding inputs when nothing is patched into them. If the input is not grounded, some tiny current may bleed into the module, which can result into inaudible noise. Another advantage is the possibility of daisy chaining inputs. Aha! This is this normalization thing I was mentioning before. In the case of the Dual VCA, if nothing is patched into in2, we can see that here, in2, the audio signal from in1 is routed to in2, applying the same input to both VCAs. This is called normalization. In2 is normaled to in1. Same goes for the CV inputs. So it means we can control or have two VCAs acting on a single signal. Awesome. So we also have a standard Eurorack power connector. We have the Schottky diodes that double secure the reverse polarity power supply protection. Okay, so we have a couple of diodes which make sure that the power is plugged in the right way around. That's what diodes do. They let current pass in one direction only. So there's our schematic. So those are some additional things which have gone to it. So next, we have two 10 ohm resistors on the plus and minus 12 volt rails with decoupling or bypass capacitors. These capacitors serve as energy reservoirs to keep the module's internal supply voltages stable in case there are any fluctuations in the power supply for the entire system. Combination with our 11 and 12, the large 47 microfarad pair, these are these ones here, compensates for low frequency fluctuations, while C3 and C4 filter out radio frequencies. How interesting. It is interesting how that you're not just designing a circuit to do the thing you're trying to do, to be a voltage controlled amplifier. You also have to deal with fluctuations in the entire modular system power supply. You've got to deal with accidentally reverse plugging in the power. You've got to deal with high frequency spikes and filtering out radio frequencies. I mean, it's nuts, really, the considerations you have to put into this. And I can imagine if you built what was on the breadboard onto a PCB, you would probably end up just having a lot of trouble with it, a lot of niggly little troubles. And so it's really interesting that you have to take these things into consideration as well. There's often another component, a ferrite bead, is used instead of a 10 ohm resistor. There's no clear consensus over which works best, but generally for analog modules that work mostly in the audio range, resistors are considered to be superior. Okay. Another advantage of 10 ohm resistors, these are this R11 and R12, which is to do with keeping the supply stable, is that they act like slow fuses in case there's an accidental short. The resistor will get hot, smoke, and finally break if there's a short circuit somewhere. Even though they aren't really fuses, having them as a fuse substitute is pretty useful. Cool. Capacitors C5 to C8 are additional coupling capacitors. Wow, if you inspect the PCB, you'll see that those are placed close to the power supply pins. Well, I'll have to get my glasses on for this. Power supply is here. If I swap back to the middle for a minute. So, where are we? Here. Power supply is here. These are the diodes which prevent nastiness going on. These are R11, R12, which are the resistors, I think, yeah, the 10 ohm resistors. These are the C3 and C4 capacitors. So all of this around here, and they're the big capacitors as well, is all to do with the power supply. It's all to do with regulating and removing interference. That whole section there is not even anything to do with the VCA. How interesting. What we're looking for, C5 to C8, are the decoupling ones. C2, C4, C7, C6. They just knock around the place. C8, C5. So the decoupling ones are kind of scattered around the place. For well-designed PCBs, you'll find decoupling capacitors next to each IC. Like others, their job is to simply compensate for unwanted noise. The input voltage drops, and these capacitors will be able to bridge the gap to keep the voltage at the IC stable, and vice versa. If it increases, they'll be able to absorb it. Okay, so before you start soldering, we highly recommend printing out these part placement diagrams with designators and values, because some of our PCBs are densely populated. This will help you avoid mistakes. Okay, now I did this with the VCO and I didn't need it at all. I think I'm just going to refer to it on here. It's good to know that it is there. Because this is labeling everything with the appropriate values. So if we're unable to see it or find it on the board itself, then it's going to help us find it on here. That's pretty awesome. It also shows us the orientation of the resistors, which is helpful. This is all good information, this, without actually taking you completely by the hand. So here we go, into a bit of soldering. So place it on a holder. Yeah, I don't have a holder. I just kind of hold it and put it on things sometimes. I start usually by populating with PCBs with the lower horizontal components, in this case R11, R12, the power protection diodes. And then the dip socket. Because looks like a lot of these resistors are going to be set up. Where do I have a resistor? Here's a resistor. So rather than being in that sort of flat orientation, they're going to be like that. So it fits into a much smaller space, which is interesting. So it allows us to keep a smaller PCB, but also means that because these stick out further, you're going to want to do all your components in height order. So the lowest thing first up to the tallest thing. That's because if you're not doing it with some kind of holder or something, you are going to want to turn it over in order to solder it, generally speaking. At least that's what I do. I know some people like to solder from the top. I'm very much a get underneath kind of person. And if you do something tall, and solder that in, which is fine, but then try to solder something shorter, you'll turn it over and it will fall out. Or if it doesn't fall out, it'll go slightly wonky. So it's just better practice to start with low-level stuff, work your way up in height. That's always a good thing. I am going to need to re-identify these resistors, am I not? So, all right, so let's follow the instructions. I'm not going to try to second guess and do it myself because of the way that these resistors are up and down. I'm going to follow exactly what your man says, roughly. So let's go back to the overhead, like so. And we are sticking in R11 and R12, which I don't know what they are. So that's why it would be a good idea to print this other thing out. I could do that. It's just printing things is often a disaster in my life. So we know that R11 and R12 are 10 ohm just by this diagram. So we can use that, and we're going to put in the two diodes as well. So we need 10 ohms. 10 ohms are these two fellas. Here, we measured them yesterday, remember? 10 ohms. And as we know, they've got brown is 1, and then black is 0. So brown, black, black will be, I think, 1. You can tell me in the what's it. So 1, then a 0, and then no more zeros, making that 10 ohms. That's what I think. Is that right? Somebody sent me a picture of the resistor rings today, which was kind of sweet, really. But you know, it's not like I've never seen them before. It's just I don't retain them in my head. And then these are the diodes, and we've got to make sure they go in the bloody right way around. Did Robin realise, we're talking about me in the third person now, that the lighter coloured resistors are factory matched? No, I don't know that I did. All I knew was that no, I don't know. As in, I've just got some which are blue and some which are not, some which are green, some which are that, some which are that. It just, to me, it just means they came off a different reel. That whether they're matched or not, or whether that kind of level of preciseness is important in this point. As far as the 10 ohm goes, I've only got the 2. I've been given no information about using one colour or not, on where to use them or not. So I'm not even... Oh, he said so, did he? So excellent, that's helpful. But so Moritz, if he said that they are factory matched, then is there a reason for that? Would be my next question. And what does that mean in terms of the build? And does the manual say use this colour here and use that colour there? It's all very well talking about these things, but what's the reality of that information? That's the question. Anyway, as no one's contradicting my belief these are 10 ohm resistors, I'm going to stick them in. So these are put in the traditional way around. Let me see if I can find it on here. 11 or 12. I need to get on with things rather than talking, because I don't know about you, but the wind last night was quite something. And I didn't get a whole lot of sleep. So I'm not planning on a late one tonight. He'll explain on page 51. Will he? Oh, let's have a look. Well, I'm just doing these two first, because these don't matter. There's only this one lot. Like that. And like that. Bend them out a little bit, so that they retain their position when I turn them over. Let's have a look at these diodes. There's only these two diodes. There's no other diodes on the board, so we can't go far wrong. Can't get the bleeding paper off. Come on, come on. So, looking on the schematic, I can see, and also hopefully on the PCB, I can see the line, which is where the line of the diode goes. So that can thump its way straight into there, no bother. And the other side, VD2 is pointing in the same direction in this case. There's the line. There's the line. Go in like that, bend it out slightly. Cool, so those are good for soldering. But what are you all saying over here? The shed does still stand, yeah. The 1% are matched for the long tail pair. Right, that makes sense. How much money do you save building your own kits? Millions. Millions, mate. Okay, conversation has moved on to other things. So, what they're saying, page 51 will tell me something somebody suggested. Let's have a look. So let's go back to what we were talking about. Thank you. Okay, cool. We'll have a look at that in a minute. So that looks like good information. So let's go back up here and just do what we're doing, and then we'll get to that so we don't jump ahead of ourselves. So we've put in R11 and R12 and the power protection diodes. Bend them, insert them. They're all printed on the silk screen. If you're not sure about it, check it with a multimeter. Orientation is critical. We did all of that. Flip it over, solder all four, and these use pliers to cut off the excess. So, okay, we're getting the soldering time now. I'm just going to put my fan on. I've moved this in order to have the microphone a little bit closer when I'm turning. Yeah, millions. It's all relative, isn't it? Ultimately. But in terms of, I mean, if you want a realistic answer to that then, rather than a facetious one, what I would say is that you save about maybe a third to a quarter of the price of a module if you buy it as a kit. If you buy just the PCB and source the parts yourself, you can usually get the PCB and front panel for a fraction of the price of a built module. You know, If you go for something like ST Modular, you can buy panels and PCBs for like 30 quid, 40 quid, and then you have to source all the components yourself. So it can be massively cheaper if you buy components in bulk or you have them for other means, etc., etc. However, if you ever factor the time it takes to build a module in, then evidently your module is going to cost in time far, far more than you would ever spend on a module buying it built. So cost is definitely a factor, and means you can do it cheaper, but purely cheaper in terms of component pricing, and not a whole lot cheaper if you're buying the kit in a bag, because module manufacturers build modules really, really quickly. So you're saving them a couple of hours maybe, as opposed to thinking that you can get it all really cheap because they're just charging for labor. I don't think they are. They don't tend to charge for as anywhere near as much as they should for labor. They tend to, the bulk of the price tends to be in the cost of the PCB, front panel and components. So you can, doing it like this, doing it DIY, you can do it cheaper. But not massively. So anyway, so safety specs and my magnifiers, getting everything all at once. Okay, I'm just warming myself up to the whole idea, and at some point you just have to get on with it. Got a bit of solder here. Is that all in the middle? We seem to be really far over. Maybe I think my camera's drooped a little bit. I'm going to bring that in so you can see nicely. Cool. All right, let's do some. So I put the soldering iron onto the ring and against the leg, and then I present some solder, and it just goes on beautifully. Take off the solder, take off the iron, heat up the next one, present some solder, squidge it in, take it off, take it off. I'm just sort of holding this steady with my finger, heat that up, give it a couple of seconds, present some solder. Oh, it's not going to want to do it this time, so just change the position of the soldering iron a little bit if it doesn't heat. Funny thing, soldering irons, totally imperfect. Put that one in there, put it against it, and then that goes on just like a good one. They look pretty beautiful. I'm going to jam it into this wire wool type stuff just to clean some of the excess off. You will get solder on your soldering iron, always. Well, at least I always do. Don't worry about it. You can just scrape it off. So that on there, heat that up against the leg. That's on there. If your legs get in the way, push them out of the way a little bit. Against that one, heat the pad, heat the leg, push some solder into it. So heat, 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 solder, solder, take the solder off, take off the iron. That's it. That's simple. Not hard. It's really not hard. That looks lovely. What a beautiful job. Beautiful job. Then you need a pair of snippers, these sorts of things, sharp things, in order to cut the legs off. They will twang everywhere, but they'll just end up, you know, in your socks or something. So it's better to keep a little bit of control over them as you twang them about the place. And then, of course, dispose of them sensibly to a magic hole I've got down here. It's the satisfaction of producing a working module. Yes, it certainly is. VOR red. Alright. So, good. Now we're on to this bit where it's going to talk about the resistors, which is very exciting. So next, oh yeah, in a moment. Next, do the dip socket. Dip socket, dip socket. So I think it's talking about these IC sockets. Okay, so question for the chat. What's the difference between a dip and an IC? So with these, make sure they're orientated correctly. Oh, I'm upside down. That'll be the reason. Okay, so it's on here. You see that? See the little nick that's on it? That's going to correspond to a little nick on the socket. So I can drop that in there. If I'm careful and clever, I can hold that tight and just tweak one of the legs so that it kind of stays in when I turn it over. This one goes that way round. See the little nick into that socket there. Similarly, I can attempt to just push one of those legs or two in order to keep it in there, so that I should be able to turn it over without them both falling out. I got away with it. I got away with it. Now, it's not going to be completely flat when I put it around this way, so if I solder just like this, they'll end up slightly wonky. It won't actually matter to the functionality, but it won't look as perfect as it could. So just try to make sure that when you push down against it, it's flat as possible, so that it's flat. Yeah. So in order to solder this bit, to get a little bit closer, I'm going to use a soldering iron to push against it a little bit in order to hold it flat in the best bit. I'm going to hold that down onto that leg. I'm going to add some solder and then going to hold it again as I remove this, in order to keep it, to let it cool so it holds it in place while it's still flat. Do for this one over here. Hold it down, heating it up, add some solder. And before I release, I'm going to hold it flat, take it off like that. Now let's just have a look at it. See, that's now soldered, those are flat, those are gorgeous. Check one more time that they're the right way round before I solder the rest of the legs. Yes, they are. So I'll do the remainder. I find IC holder legs very, very satisfying because they heat really quick, and you can just go along in like a nice long line, if you've got larger ones, of course. And the solder tends to go on and look exactly like it's supposed to look, unlike with thick old resistor legs where they can be all over the place. Now it's that one I didn't quite put enough on, I don't think. I know that some people like to put the absolute minimum amount of solder on stuff, but I find I need a solid amount on, a confident amount on, so that I am absolutely sure that it's on there, to the point of having a little bit too much on, if anything. Always give them a look, just check to see whether you've accidentally dragged solder from one pin to another, which would cause a short. No, that's looking good. Am I doing this on the right side? I think I am. Yeah, I think I'm doing that right. Good. Right, so now there's something where people were talking about the thing. 11 the Big O in the filter. Nice. Funnily enough, I was thinking of putting the Big O back into my live performance rig. So I've been using the Castor and Pollux a lot, which is great. But the funny thing about the Castor and Pollux is that it's very, very loud compared to anything else. And that is causing me a few sonic problems. So I think I might swap in Captain Big O to see how that compares. Because it's got some interesting wavefolding bits and pieces in it as well. I think that might be interesting. So yeah, you know. Oh, Ken, thanks. DIP is dual inline package, which is a leg configuration used by integrated circuits. So they're the same thing, basically. The legs of the IC are in two parallel lines. But, okay. But then all legs are in parallel lines, aren't they? P is for package, right? Because, as I understand it, all this does is takes the leg and poke it through the hole. These aren't connected to each other in any way, shape or form, are they? It would suggest that they are, but I don't believe they are. Are they? No, they're all individual. Anyway, that's probably an argument for another day. It's probably just two different ways of talking about something coming in, crashing into each other. Okay, so it looked like that. It does look like that. Oh, we've put a whole bunch of capacitors in while we weren't looking. See, that's cheeky. Now take a close look at the part placement diagram. Some resistors are marked with an M. So I'm just going to check, because I'm now going to start doing resistors, and I haven't put in these capacitors. So if we look on here, I'll just change that around. Dates back to 1964. No, that's what I thought, Gary. I absolutely thought that. So back to our thing here, and you can see all of these ceramic capacitors have been put in. Now, there's been no talk of them particularly. I mean, we've mentioned them in terms of what they're doing, in terms of smoothing things out, but it didn't actually mention putting them in. It mentioned putting in the dips, which we did. So we should do that. Now, these, I believe, are all the same, if I remember from the very, very helpful bill of materials. And there are 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 there on that board. And they are 3, 4, 5, 6, 7, 8. Yeah. So there's a little stage missed there where it just could have had half a sentence to say, also put in the ceramic capacitors. So that's what we're going to do. So these are not electrolytic. They don't have a polarity. They go in any old way. So there's 3 there. It says on the board 0.1 microfarad. There's 4. Just push the legs out underneath. 5 is on this edge, 0.1. As you can see, they are slightly higher than the dips, so it's good to put the dips in first. 6 is here, 0.1. 7 is there. 8 is here. Lovely. So turn those over and give them a bit of a solder. So apparently dip refers to the IC. So an IC is a dip, and these are an IC holder, therefore a dip holder, or something. I don't know. That's the idea, I think. So it's kind of interchangeable. There's a level of kind of, yeah, you know, whatever in electronics, which I really enjoy. I enjoy the kind of how it's all done a little bit haphazardly. You kind of expect a certain amount of precision and science going on. Whoops. When often it's like, well, yeah, that'll probably work, or that'll do, or it doesn't really matter if it's that or that. Let's call them 3 different things. It all kind of means the same. I like that. So those are all in. You could solder a socket backwards, just can't put the IC reverse. I mean, you can put an IC in any way up you like, really. There's nothing about the dip socket, the IC socket, that would orientate the IC, except the fact it has a nick in the front, but it doesn't physically prevent you from doing anything. It's similar to the screen print. You can get it right, you can get it wrong. Okay, good. Right, so now we're going to take a closer look at a few bits. So this is hopefully going to be enlightening. Oh, have I been doing all of this while still having the manual up? I am sorry about that. Anyway, back to the manual for a second. Now take a close look at the part placement diagram. Some resistors are marked with an M. These should be matched in pairs as similar resistances are as these should be matched in pairs with as similar resistances as possible. Okay, normally you'll need a bunch of, say, 20 kilo ohm resistors for this. You would check each one on your multimeter and select pairs with matching resistances. They don't all have to be 20 kilo ohms exactly, it's just important that the two individual values are matching. I've done this before on another build, it's a right pain in the arse. They don't have two resistors of 19.98 kilo ohms resistance, for example, would be perfectly okay. But as this is a pre-assembled kit, we didn't want to just drop a big pile of resistors on your head. We pack it with plus and minus 0.1% tolerance resistors where needed, which means that there's no real need for matching. They're going to be close enough straight out of the box. You can identify these because of their light blue bodies. Light blue bodies. Okay. All right. So for those who enjoy the pedanticness of life. Which one is light blue? Is this, because this is kind of a green, and this is kind of a regular blue. I wouldn't say that as a light blue. It's just like blue. This is more of a green. So, which one is light blue, would you say? See, not all ICs are like ICs that we usually see. There's always an IC which is going to be different to the ICs that you think you've seen before. So don't get familiar or confident about your IC shape and stuff, says the man in the comments. Fair enough. Yes, the greeny ones are light blue, are they? I hate resistors too. No, I don't. I like resistors. I think they're remarkable. I mean, it boggles my mind on how these things actually function. So what I'm going to need to do is make sure I've got everything, all the proper bits in the proper place. Because I got into a bit of a disarray because of the breadboarding. So let's just make sure I've got everything right. So that's 10K. So for instance, I've got 10K green and 10K blue. Just a second. So you can identify the plus and minus 0.1% tolerance resistors by their light blue bodies. Use them wherever you see an M. If you're unsure about a resistance value, use your multimeter to double check. Yes. I mean, shall I check these just to have a look on the multimeter? I mean, you know, we're here to try to learn something, and this is something that I've never encountered before, as well as the interpretation of colorings, which is a whole other level. That is. Whole other level of uncertainness. But if I was to measure them, just to see what the difference is between them, maybe that would be some way of giving us a bit more confidence. Bring this out. So this 10K, these are the blue ones. Wouldn't say they were a dark blue exactly. I'm the sort of person that drives people like poor old Moritz completely bonkers. So it's 9.92, that one. Remember that number? I'm going to try the other one. 9.93. All right. $10. Look at that. 10 on the dot. That's pretty good. I like that. But the point is that this one should also be 10 on the dot. Where's nearest, damn it? Yeah, look at that. Look at that. And the third one? Yeah, I've messed that up because I've got the other one still in its jaw. 10. Well, he's not wrong. He's not wrong. So we are going with the greeny colour, the light bluey green, let's say, are the ones that need to go onto the spaces which have an M next to them. It's pretty packed in here. Okay. Alright. Cool. So what I want to do at this point is just to get back some of these resistors. So I want the 10K, that is the 10K. So I should have 4 of those, 5, 6 of those, I think. So that's 10K in there. Just trying to have these in the right way. I've got an 82K now. The 82K, I think, is that one. Yep. That's 82K. Put those together there. What have I got here? 100 ohm. It's got the big brown ones on the end, which I think was there. That's 100 ohm. Yeah, there should be one more. Yeah, so that's 100 ohm. Those are 20 ohm. No, hang on. No, there was 10 ohm, the other ones. 20K. I've got some missing. See, I would have said those were light blue compared to the darker blue. Anyway. 20K, I should have 1, 2, 3 of these in here somewhere. 1, 2. Yeah, those 2. Yeah. 3 over here. 20K. But it only matters if I've got 2 different types of one resistor. That's the only place it really matters in this scenario. Those are 1Ks by themselves. So the rest of these are probably all hundreds. Oh no, that's not. That's something else. No, no, they are. Brown, black, black, orange. Brown, black, black, orange. Brown, black, black, orange. Yeah, they should be all hundreds. So I had those ones. Then I had these 4, which are all 100. So what is this one? Is this the 10? No, I used the 2 10 ohms. This is brown, black, black, something. Is that the 100 ohm? Is that which one this is? Let me test it. Let me test it. Is this 100K? How have I reading that wrong? No, it's just 100k. All right, going out of my mind, obviously. But, you know, when in doubt, test it. Always a good thing to do. Right. In order to save space, some projects, including the Dual VCA, have vertically placed resistors. So the next step is to place and solder those. Bend the resistor's legs so its body aligned with both legs, and insert it into the designated spot. Then solder the longer lead from the top side to secure it in place. Turn it around and solder the other lead from the bottom. Okay. So what this is suggesting, which is interesting, and I will do it, I think, is that when you put a vertical resistor in, that you should solder the long lead from the top. Because one of the things I thought when putting them in like this is that it's really hard to solder the base of that resistor, I would say. So you solder this one from the top and then that one from the bottom. Interesting. I can see that there's room for me to completely mess that up. But let's go with it. So how am I going to place these resistors in the right place? And we're going to do it off the board. These really are packed in here. Couldn't I? And I could try to do them in order. I don't think that's really necessary because I don't have a list that tells me what each of them are. It's just what it is on the board. I'm making sense to myself. I may not want to be making complete sense to you, but that's okay. Right, so I'm going to sort of double check this by going back up to the larger diagram, this one here. And I'm just going to start at the top and work my way down, I think. So, R37 is a 1K. Here's a 1K. I've got R38 at the other end, which is a 1K. So let's put both of those in. That seems smart. That seems smart to me. So I'm going to bend these so they're vertical. Going to bring this in a little bit. Seeing that all right? Good, good. All right, 37. So I guess the circle on the PCB is where it wants the resistor part of the resistor to be sitting. So the longer leg goes through there. Problem I'm going to have is putting this down. Oh, it'll be alright. I'll just spread the legs like I normally do, if you pardon the expression. So 38 1K is down here. Again, long leg in, like so. Cool, now I've got myself on a wonk, that's nice. So what's next? These top three, R6, 100, R7, 100, and then an 82. So I've got two 100s, none of these have got M on them. Do they have M on here? So I'm not messing this up. No, I'm not messing this up. So if I'm using the 100K ones, I need to be using the regular blue ones. For R6 and R7 up here. R6. Alright, let me bend that a bit better. That's just sticking out like crazy business. Okay. R6. Ks. 7. Looking a fair bit wonky to me. Okay, I think just before this gets too out of control, I'm going to solder these bits in, just as a starting point. So from the top of the board, I'm attacking the leg that's by itself without, hopefully, without melting the resistor. So that's on. Heat this one up. Got to be very careful that you're not melting against something else when you're soldering on the top of the board. Good, good. Got a tug on my soldering iron cable, that's always nice. So these two just need to be a little bit further apart to make sure I'm not shorting anything out. So now we turn them over and solder the leg that hasn't been soldered, and you can see it because the solder comes through the hole. I was worried that I would mess that up and end up missing something, but no, that's impossible to miss, I think. So let's do the other leg. The light appears to have recovered suddenly from wherever it was that it went. So the other advantage of doing resistors which are scattered around a little bit is that it maintains the stability of the board as you're trying to press on it when you're soldering. Good, take those legs off. Ooh, itchy nose. Okay, cool. Right, back on this side. Let's do the right way up. So we've got 100k Ms for R33 and R35. 100k Ms. So they're the lighter coloured ones, the greeny bluey ones. Whoops. Okay, straight back out again. Oh no, I'm in the wrong hole. No, I'm not. I'm in the right hole. Like that. That's the right place. Okay. Now I can do a couple of 10k Ms, so the lightly coloured ones for R30 and R29. 30, 10k Ms, that's what this is. very similar to the other one. Alright, so here's a flaw then. If I put those in, I'm not going to be able to solder the one behind it. Okay, so here we're learning. So this one needs to come out. I'll just take them both out. Right. So let's not put those two in just yet. Sorry, everybody, let's rewind a second. Let's not do those because you're hiding those ones, and therefore that's going to make a complete mess of that. So I'm going to do R3 20k over here. R3 20k. 20k. Is that 20 ohm? 20k. These are just regular, not M version ones. 20k. Then I've got a 20k M. Oh. Dum 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 dum. Is that what that is? Is that a 20k? Yeah. Okay. So 20k M is next for R17. I can still get to that and solder that one and solder those two just about. So I'm going to keep on adding a few more just yet. R25 is 100k, a regular 100k. I've got R23, which is just a plain old 100 ohm over here. Now, I've only got light coloured ones of these. It doesn't say M next to it. Let me just check to see if there are any 100 ohms that have an M next to it. No, there's just 4, and they're just what they are. Okay. So R23 is 100. R21 is 20k with an M. 20k with an M. Got to be careful. What is that? So where does this go exactly? It is following this line. So what is that? Don't think that's anything. Okay. think it's a test point. Right. Continues in a line then. Oh, 18. Okay, so the screen print, the writing for these other resistors down here seems to have been put the other side of this variable resistor thingy, this trimmer here. So there's R18, R26 and R24, which refer to these bits over here. Yeah, so if you're wondering where that writing has gone, it's just moved over here. But using the bigger schematic, the bigger overview, you can see that they're all in a line. So for R18 is a 20k M again. Oh, 20k. What did I do with that? Is it this one? Have I lost one? So I did R21, 20k, red, black, black, red. Oh heck. Did I have two left? Have I spun it off the table or something? Alright. I don't know, that's a little bit weird. Probably caught in my sleeve. Alright, I'm not going to worry just at the minute. I'll come back to it. I might have done something stupid while I was thinking about something else. How annoying. Well, why don't I put all these ones in just now and then worry about the other one in a minute. So I've got a 20k one up there, which is that one, which is there, which is one of those, which is right. Then I've got a 20km, yeah, there. Then I've got 100. Okay. $20k. R3 is 20k. Yes. R17, 20km. Yes. 25 is 100k. Regular. Yes. 23 is 100. Yeah. 21 is 20k. Yeah. And then 18 should be another one, which I don't appear to have. Alright. So, okay, if you lose something, don't panic. It's always the best advice. Is that it? Yeah, that's it. No, it's not it. That's definitely 100 ohm. Yeah, don't panic, he says. Alright, it'll turn up. I'm just going to solder these ones here before I lose my track, and we'll come back to that. I can always fish something out from something else if needs be. For the moment, I need to do the top end, so I've got to be very careful not to melt anything. I'm not particularly enjoying vertical resistors, I have to say. I mean, they save space, but they make soldering a little bit precarious. So you can't see that. Let's try to do that better. Remember, look where the iron is going, so you're in no danger of melting something, particularly dip socket. Oh look, I just soldered the bottom of that one next to the resistor. Oh well, that's okay, as long as it works, because it was a little bit raised, so I was able to get the soldering iron in there without melting the resistor itself. Cool. This one is tricky. Good. Great, so that's all them soldered on one side. Now I'm going to solder the remaining leg. Good. All of mine are wonky. It'll turn up. Right, so that's a bunch of resistors. Let's carry on. I need to do these two up here I didn't do before, the 10km. Two 10kms are R30 and R29. Horizontal, vertical resistors, they just take longer to put in, longer to solder. Okay, that's good. Have any more resistors down here? Yeah, I certainly do. But am I going to need to get to these ones first? Okay, I'm just going to solder these two, because I'm worried about getting access to them later on. I'm also definitely experiencing this idea that if I had a holder in order to hold them so it didn't sit on the bottom quite like that, that might be better. So maybe I should do something about that rather than sort of struggling a bit. I could improvise something like this so that they sit nicer. See, that might be nice. That might be nice. cool. Good. Cracking on through. See, those two are nice and straight. Look at that compared to all this other rigmarole going on all over the place. So, moving down. R19 is a 10k, regular 10k, regular 10k. R19. There. R5 is 100k regular. R13 is a 100 ohm. R20 is a 10k regular. R8 is 100k regular. R14 is 100 ohm. I think I should solder all of that lot along there rather than trying to do too many at once. A little bit tricky. Can I better do this? there's a bank of stuff around here. Again, I don't want to be able to block that one. So R34 is 100 km. $3400 km. 32 is a 10 km. And 36 is 100 km. 6. Right, I'm just going to get straight into those. Don't worry about running out of room. Already it's going to be tricky to get to that one. Yep. Oh, that was just totally over the end of the soldering iron, not into the hole at all. Good. So R31 is a 10 km, last one of those. So let's look further down. R16 is an 82. Okay, 82 over there. R16. Have to do that one kind of now, really. Alright, these little short bursts of resistors. I'm kind of used to doing 50 at a time. Careful not to heat anything up that I shouldn't be. R10 as 100k. Ah, oh, bollocks. No, I did do it right. Cool. For a moment there, I thought I'd soldered this R16 across the wrong bit, but no, I haven't. It's down there. There and there. Let's move that capacitor out of the way a little bit. Cool. Phew. Thought I'd royally messed that up. No, not quite. Getting away with it. Another 100k. Which is there. R9. I've got R4, which is a 20k. Which is what these are, yeah. Yeah. And then I've just got those bits in the middle, so let me finish these ones off. If I can get in around it. Okay, so the last lot, I've got these 4 in the middle, and I have 1, 2, 3, 4, 5 resistors left. That's interesting. Alright, so maybe I haven't covered them all quite yet. Let's just have a look. 1, 2, 3, 4 there. Is there another one that I've missed? Yep, that one right at the top there. That's fun, isn't it? So again, 82 right at the top. And then these 4 down here, 20 km, 20 km, 100k and 100. Right. Let me do the 100k. That's 26. 26 is that one. 26 is that one. That's 20k. This is 100 ohm for 24. Gonna hit. I have the impending doom of a problem. Which I'll come to in a minute. There's 100 ohm, which is there. So let me get these ones in. Oops. Oh, the light's gone again. Just a little bit. Right, nearly there. So I have two bits left. 2 spaces left on my board for resistors. Here and here. That is R18 and R22. Now both of them are supposed to be 20k M's. All I have left are regular 20k's. What do we do about that? Is that even important? Because I have regular 20k's here on R3, and I've got a 20k M next to it on R17. So I've used both regulars and M's on the board already. And these are these identical? 20, 20k M, 100, 100, 20k M, then 20k M, 100, 100, 20k M. So yeah. R4 is a regular 20. Yeah. So that leaves me in a bit of a pickle. In a bit of a pickle, that does. Let me check. Because these are supposed to be the M versions, and that's not what I have. That's not what's in the kit. So, what does that mean? I don't know what that means. It just means that it's not exactly right, and that's frustrating. Now, on the side of me which kind of sees electronics as a bit of a yeah whatever, says yeah whatever. So that's 19.9. They don't have to be 20, they just have to be next to each other. But then are these going to be the same as the other ones that are in there that are important? 19.9, well, at least those two are the same. So there's not a whole lot I can do. I don't think. I can't fix it. If I was cleverer about it, I suppose I could create some kind of symmetry, or at least test all of the 20k ones to see how far away they are, and make sure that the ones which are the most far away from each other are used in the regular 20k spots. But I've been working through them in in no particular order. I wasn't guided to a particular order in working it out or anything. But these ones, these two here, should have been the green coloured ones. but there aren't, and there's not a whole lot I can do about that. Yeah, the chat's just minding their own business, which is fine. So what I'm going to do, I'm going to use these standard 20Ks and put them in where those M's are supposed to be, and just hope that that's all right. Now this is modular, it's not an exact science. If something doesn't quite follow the same curve as something else, then hey, what are you going to do? What I'm not going to do is desolder all the other 20Ks just to check. But essentially, these two are going to go on VCA2 on this side. So potentially there's possibility for VCA1 to be slightly better than VCA2. In what context and what that means, I have no clue. So I'm just going to go forward with doing what I can. So I didn't lose a resistor. Don't know why I felt that. Well, I felt it because I had no longer had any of the green ones left. Any last thoughts before I solder them in? No, there's no way. There's nothing I can do. I don't have any more resistors. Thanks, Skull. Do I have any spare parts? No, I don't. I think they just had to be the same, so it should be okay. Yeah, I know what you mean, Ken, but I don't know if they're exactly the same as the other 20KMs. That's the point. That's the point. No, I wasn't. No, please don't, in the chat, don't think I was being critical of you talking amongst yourselves. That's brilliant. You're absolutely welcome to talk amongst yourselves. I don't need you to be hanging on to my every word. Don't you worry about that in the slightest, fellas. Ladies, no bother. That's not what I meant. I was just, I was just looking for some comments, and that's quite all right. Don't you worry about it. I am thrilled that you are here at all. Oops. I'm just putting them in. Trying to get this one in without melting any of these other resistors. I mean, it's always interesting making videos on these kits, and this is, I think, one of the reasons that I do it as much as anything else. Yeah, all the other 20Ks are in the right place, yes. Good question, though, but yes, they are. I've checked that now a dozen times. Well, I say that. Should I check it one more time? I mean, there's only... Right, okay, so let's just confirm absolutely everything. How many 20Ks are there in the first place? Let me go right back up to the bill of materials. Up the top. 20Ks, there should have been 6. Okay, back to our sheet. Now, the 20Ks are... There's R3, which is this one here, which is a blue one, 20K, yes. So that's 1. There's another 20K, which is R4, which is at the opposite side, which is this one here, which is a blue one, yes. 2 blue ones. See, I think I had 4 blue ones and 2 of the light green ones, which are supposed to be the M's. According to somebody in the crowd, maybe it was the other way round. Huh? Had you thought of that, eh? But then I measured them, didn't I? Yeah. I don't know. ambiguity in the manual. Light blue is not descriptive enough. You have to do better than that, Moritz, I think, because I'm left now with a conundrum where I don't actually know whether I used the right ones or not. Was there an uneven amount with other ones? I can check that in a minute. Anyway, so 20Ks. So the rest of the 20Ks are all in this gap here, and they should all be the light blue. Unless I've got it backwards. Right, so let's have a look at the 100Ks, because there's the most of those, but then was it the same amount of each? That's the problem. They need to have a different amount of each. Let's look at the 10Ks. I think there was less of those. Is this a wild goose chase? Could be. Could be. A bit of materials. So 10Ks. There's 6 of those. Let's see if that correlates. 6 of the 10Ks. So 10K. So I've got 2 10K Ms at the top. And I've put in the light ones, 2 10K Ms. So I've got 2 of those. Then I've got a regular 10K on the darker blue. Yeah. Then I've got a regular 10K on the R20 down here. Yep, on that blue. And then I've got 2 10K Ms at the bottom on the light green. So as far as the 10K is concerned, there's 4 of the light green, 2 of the blue. And that matches up for the Ms. With the 20K, I've got 2 of the light green and 4 of the blue. So I have the opposite arrangement. So if I'm assuming that I had it right the first time on the 10Ks, it means that the components in the box on the 20Ks are wrong. Proven. Yeah? Okay, Robin, thanks for that. And that was important. I know, but unfortunately, the kit is not correct. So that's now become unimportant. Yeah, the tolerance. Yeah, no, fair enough. And that's worth checking. So the tolerance on, if we look at the 20Ks then, I've got the 20K have a red tolerance. Regular 20K has a purple tolerance. Can you tell me what the difference between those two is? So I've got a red, I think. No, red is 2, isn't it? So that's not right. So I've got brown tolerance. Let's get this right. Brown tolerance on the, what I think is a 20K purple tolerance on the regular one. That way round. Which end is buggering me? What? Who? You're getting some buffering. I'm sorry about that. It's probably the wind. I'm just checking over here that it's working. It seems to be working all right. So yeah, if anyone could look up the tolerance, that would be great. Otherwise, I have soldered these in now. No, I haven't. Well, I am going to, because there's nothing. Oh no, because am I going to pull those out? But no, I can't, because there's the. Well, no, I could, because if they are backwards, then I could change it at this point. One is more accurate than the other. Thank you. So which is it? I can look this up myself if you like. I just thought you were all on the buttons over there. Let me have a look. So resistor tolerance. See, I'm going to have to do it, spell it out. I don't even have a keyboard. Resistor. Tolerance bands. Boo 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 doo 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 doo. Is this gonna wall chart images? Something helpful? Tolerance. So brown is plus or minus 1%. So it should be the ones that have got brown on it. That's what we're saying. Which is the light coloured ones. They've got the brown, I'm pretty sure. Because red is 2, yeah? Yeah, okay. And is that supposed to be silver? Is that purple honestly supposed to be silver? Because that's pretty terrible. Could be violet, but even so, that tolerance is also bad. What am I looking at? What am I trying to look at? Yeah, I don't think that's got me anywhere. So it should be the brown ones. It should be the light blue ones. I've only got 2 of those. I've got 4 of the dark ones. I have to put the dark ones in. That's the answer to that conundrum. That's all I can do. I can't worry about it. It's going to be interesting to see. I don't know how a multimeter would help, Gary. We know that they are 20k and that they are similar to each other. It's going to be more difficult for me to measure resistors that are already soldered in. I think we're going to have to just move on at this point. So yeah, note to Moritz then, that just got to make sure that those, or to Erica Synths, whoever it is who packs up the packs, got to make sure that you have the right number of each one. Check and check again. Purple is 0.1%, which equals M. Is it? Violet is 0.1%. Oh, for fuck's sake. So what you're trying to tell me but that's not what I had in any of my pictures. I didn't have violet. No, okay, I see what you're saying. Okay, all right, no, it's sitting there looking at me. All right, well, they're in now, and I'm not that fussed, to be honest, at this particular point. If it requires changing, I will change it. I will change it later. All right, so we're continuing this saga then of what the heck these resistors are, and a reason why it needs to be. I mean, adding the bill of materials to the manual was awesome, and that was a right step in the right direction after the palaver we had with the VCO. So having the bill of materials is great, but a description which says light blue, really, when you're talking about resistors, is not going to work. It's not going to work, particularly when I've got 2 different shades of blue. And the light blue for one thing seems to be light blue for something else. And yeah, not good enough. That needs better. That needs something better, I'm afraid. And I don't mean to be forceful or upset about it, but it's slightly upsetting, I should say. So what do I suggest for people who have this kit already or are going to try it? What it appears to be with the 20k ones, that the ones with the purple resistor, the purple band on the 20k resistors, they seem to be the M version. And that's that one there. I've got my thumb on, yeah? And it is slightly lighter than the 100k blue ones, for instance. Now the green 20k ones, they've got a brown ring, and they should be the standard ones. So as it goes, this top one here should be light green. Shall I desolder them? That's what I'm saying to myself now after I've just soldered them. and swap those around. I mean, I'm going to have to take them all out, put them all back in again. 6 resistors. Is that a huge effort? What time is it? Yeah, it's a huge effort. I've been doing this for 2 hours. I don't have time for that. So I might come back and do that. But if you're doing this yourself and you've watched this through before you've attempted it, then it looks to me like, I mean, I'm going to try and get confirmation on it, but it looks to me like the one with the purple band, they need to go in the M position, and the greeny blue ones need to go in the non-M position for the 20Ks. For everything else, it's the opposite. The greeny colour ones are the M's and the blues are the regulars. Got it? Is that could it be any more confusing? Probably not. Probably not. Let's move on before it all gets too much for us. Right, so that's all the resistors. So we did all that, did all that, did all that. Once you're done, you should look something like this. Should be fine, says Steve. Nice. I'll go with that. Does mine look like his? Oh, well, you see, I could have used this picture. That would have helped. But it doesn't help at all because his blues and his greens are all over the place. Oh, that's just brilliant. Look at that. So at the top here, I've got, let's put it here, I've got green. He's got blue. I've then got 3 blues. He's got green, green, blue. Oh my lord. And then for his 20K at the top, he's got green. He's got green on the 20km. And no, on the 20K, he's got that. And then on the 20km, the one directly beneath it, he's got green again. So yeah, you're kind of talking a little bit of craziness out of one's backside there, I'm afraid. Never mind, we've got through that now, and it's been an interesting discussion to work that out. I don't know what it's achieved ultimately. Maybe what we should have is have all the resistors to be the M version, and then there won't be a problem because they'll all be good. That would be better, wouldn't it? Right, next up, transistors. Make sure you place the transistors in their designated spots. Right in the middle, 2 pairs. Got it. See on the screen print that is that right? Yeah. Okay. Back there. See on the screen print that you've got it the right way round, that it matches up with what's going on with your here transistors. So you can put them together as a pair. They always offset the holes for soldering, so you've got these 3 legs which are all nicely lined up, and then they're going to want you to bend one in a funny direction, usually towards the flat bit, like so. Whoops. And then that goes in. Yeah, I was saying earlier, one of the reasons why I like to do these films is, although it's frustrating, it does highlight how it's really, really hard for a manufacturer of a kit to get it exactly right. It's really hard. You know, you're so close to the project, you can't always see, cramping up, can't always see the wood for the trees. And it takes, and you know, and whenever somebody tackles a kit and it's not quite right, you just get your way through it. You fumble your way through it and do your best. And out the other end, you either come out thinking, well, that was bloody hard, I'm never doing it again. Or you come out with a sense of achievement, one or the other. And what I hope to do through doing this sort of thing is to crash into those problems for you, so that either we have some sense of camaraderie because we're all encountering these same sorts of problems, or it will help you avoid those sorts of problems. And also, hopefully, it will help the manufacturer just make some small adjustments to make it a better, smoother build. That's my hope. And I think that's useful. And because I'm going to be building these anyway, because I just really enjoy it, I thought, why not spend the time? Alright, anyway, waffle waffle. So those are going to shuffle themselves into those holes like so. Orientation is important here. Yes, yes. Yeah, there's two more now that we haven't used for the other one. Bend it a tiny bit. Flat bit to flat bit on the silk screen. Oh, that went down nice and further. We'll do a bit of that. That's good. This one. That way around. That flat to flat, flat to flat. Lovely. Those go in. Then it's time for the capacitors, so I'm going to solder these bits in now. If they're all the same, how would I learn the lesson? Yeah, alright, okay. Fair enough. It's all a learning experience. These are weeny little holes, weeny little legs. Time is getting on though. Get a bit conscious of that. So to improve the manual then, just thinking about that whole tolerance issue, you could just add just a tolerance chart to the text. Just say that, you know, the tolerance band you're looking for on the resistor is this, and that way you could confirm it one way or another, as opposed to send the person very doubtfully out there struggling to find the answer themselves. So maybe that would be the best way to do it, rather than describing them as light blue. Say you're looking for the ones which have this band. That would perhaps lead you into learning a little bit more about the banding on the resistor. That perhaps is a more measured way of doing it. Right, next, insert and solder the electrolytic capacitors. So this is all the stuff around the power socket, around this thing. We're going to want to do the power socket first. Oh, I don't know which way around the power socket's going to go. That's interesting, because these are a little bit taller, I think. So in terms of height, I'm actually going to do the capacitors afterwards It may be that the capacitors he had are slightly shorter, difficult to say, but because the power socket and the trimmers are slightly shorter than these, yeah, I'm going to do these first. So power socket, make sure it's in the right way round. As far as the power socket goes, I've got this corner cut off on the silk screen, and that's going to indicate the side that the gap goes, the key goes. That's my understanding, and that's right according to the picture. So I can do that there. These are similar height. These are taller too. So I think I might just put this bit in first. And then those and the capacitors are about the same, so I'm just going to put this in. The arrow pointing to the first pin is aligned with a notch on the silk screen. Key to the socket will be facing inwards. Right, that's what that's doing. So in order to solder this one in sensibly, it's going to be too high. I'm just going to want to place it down on here and then hold it down while I do a pin and check it. So I'm going to push down so it's nice and flat, try to get it more or less central. Have I got this right? Yep. Put that in and then try to hold it while I take the iron away without burning my finger. That looks pretty good. I can do the rest now. I'll start with the opposite corner. And I'm just going to hold it again because it's still quite flexible when you've only got one thing soldered. Getting nice lungfuls of carcinogenic flux just at the moment. Is my fan pointing in the right direction? Not really. Okay, so that's in. So now I'll go back, put in the electrolytic capacitors. Now these are need to be orientated the right way. You've got the long leg, which is positive, short leg, which is negative. Long leg positive, long leg positive. So have a look at the place where they sit, which is here. Now, what does it say? Positive lead for each electrolytic capacitor is longer, yeah, long leg positive. There's a minor stripe on the side to indicate the negative. On the PCB, the positive pad has a square shape and the negative should go into the pad next to the notch on the silk screen. So you see here, that's the notch, they're saying, that flat bit there, that means negative, the square thing means positive. I would like to stress though that I have seen square pegs meaning all sorts of different things on PCBs, so don't assume every time that that's positive. Find out. You need more information because you can't trust a square thing to be positive every time. It just ain't so, at least in my experience of Eurorack kits. So long leg positive. So these actually orientate the same way. You often find them opposites, in fact. So let's put these in. Now, because of the bendy legs like that, I don't actually need to have them rest necessarily. So I'm going to go with that. Are these caps black or light black? They are black. Okay, whatever. Right, so I've got these two things which I believe are the same. Let's go back to that bit. So all these two trimmers, yes, because we're building two VCAs, so these two are the same. They need to have their, if I have this around the right way, so I know what I'm looking at. They need to be the right way round with their little nodule where it says so on the prints on the silk screen on the board. Oops. Okay, so what am I doing wrong there? Nothing, it's just not quite squeezing into the right space. There we go. I'm going to bend those out on the back. Good, solder them in. Try not to waste too much time. Kurt, yeah, welcome to my channel. There's aching, yawning space of slow form video making where we watch some idiot do some soldering while commenting on how he could be doing it so much better. Or, as this lot are, just being really nice and supportive. It's lovely. That's better. Gone a bit roundy. But the purpose of it, Kurt, if you're just tuning in, is that this is supposed to be an educational build. So I'm going through it as methodically and slowly and verbosely as possible, so that absolute beginners should be able to follow my haphazard adventures while they're doing their own one. Cool, those are in, right way up. It's all looking like it should, I think. Good, good. Next, 54 of 60, 55 of 60. We're nearly there, everybody. Now turn the PCB around and inspect the solder joints. Core, bloody hell. Yeah, okay. Oh dear, yeah. Now if you're really good at this, you'd get some kind of toothbrush out and some flux remover and start cleaning the thing. That's not really my scene, man. So no cold shoulder joints, which means solder that's not actually attached to the base, and no bridging, which means solder that's gone across from one thing to another. Now that's not exactly bridged, but I can see a little splash there which I'm going to cut through. Cool, okay. Clean the PCB to remove extra flux if necessary. Yeah, which is what I just spoke about, but I can't tell you how to do that because it's not something that I really do. Insert the jack sockets and then solder them. Right, not messing about. Good. So we turn it over. Jack sockets, 1, 2, 3, 4, 5, 6. Then the knobs are going to go in the middle. Easy peasy. Now, I did this thing before where I put the front panel on in order to secure them in the right place, and I still like to do that. In fact, shouldn't it say, no, it says solder them, as opposed to don't solder them yet. Alright, so I'm just gonna do this slightly differently. So let's put all these in. Do you see you've got 3 pins on your jack socket? You're going to have the twangy one on the outside, officially known as the twangy one. That goes into there. and you find that if you push against that, it kind of goes in really nicely. Now what I'm afraid of, if I solder these in, is that they'll be a little bit skew width, and then I'll have trouble putting the front panel on. I've had that in the past and it's a killer. So although they sit there relatively straight, yeah, they really do. So I don't think there's too much danger of that, but because I'm worried about it, I'm not going to solder them yet. I'm going to put the knobs on, then I'm going to put the front panel on, then I'm going to solder it. And that way I know that they're going to be right. So with these, there's two of them. Again, they're the same because we're talking about two. Bend that back from where it was bent for our breadboarding. So these are the same, so there's two VCAs in here. So I'm going to just stick that in, hopefully with no bother. yeah, no bother. There we go. Cool. This one in. Like so. And these can be off in slightly different directions, which is why Moritz is advising that we do what we do. But I'm just using that same philosophy to make sure that the patch sockets as well are right. So we're going to put this on here. See this hole in the middle? Shouldn't be there. That shouldn't be on yours. It's on mine because mine was a slight pre-release. And that might also be something worth bearing in mind when we're thinking about those resistors. It's possible that because this was a pre-release version, that's the reason why I didn't get the right 20k resistors. Well, no, I did get the right ones. See, I'm talking rubbish now. No, I did get the right ones. It's the interpretation of their colouring which was at fault, ultimately, and the lack of explanation. Okay, so these don't have screws on. So this is a thing, isn't it? because these are the sort of pots that don't have screws, they don't have a screw thread. When I turn this over, it's just going to fall out because the patch sockets are not soldered. So they're not going to hold the front panel on, even though I've put these little screws on. Oh, rats. Which means I do sort of need, so there is a bit of play, maybe it's just going to be alright. I do sort of need to solder those first, because what I was expecting was to have a screw thread on here which holds the front panel on, which also holds these on. So I'm going to rewind and do what I'm bloody told rather than trying to be clever. So I'm just going to pull these out. Now obviously turning this upside down, all these are going to fall out. So I've got to hand just a bit of sort of stiff plastic or cardboard, potentially anything, which you can sit on top like that, squeeze it together, and then sort of slide it on carefully. Yeah? And that means that they are all underneath nicely flat. So I'm going to take Moritz at his word that these will all be flat and the front panel will be no bother, and I will just solder them in. Non-threaded bezels. Yeah, you get that on the smaller pots. So I'm not going to try to push against these too hard because I don't want to change their position. Come on. Excuse me. Why is this taking so much time? Just excuse me 1 second. Quality TV this, you know. Okay, so those are on there. Put these back on. Front panel. Let's get this round the right way, like that. Yeah, no problem. Look, no problem at all. So now if I put a screw on here, just to hold it in place, and at this end, time is it? 10 o'clock. Okay, flipping it. Building modules takes time. You know, when I video building of a kit, yeah, I've often got about 4 hours of footage to try to deck down to about an hour, time lapsing and such like. That's often what it takes. You know, it's a whole afternoon, a whole evening, usually. And then here I am talking all the time as well, which doesn't help. Okay, then go ahead, solder the potentiometers. Now, see, these are all stuffed in here amongst all sorts of garbage. So you've got to be doubly careful with your soldering iron so that this is all going to happen. Almost done, okay. So I've got to get in here to these lugs and to these bits. Don't melt things, don't melt things, don't melt things. Ooh, it's moving. The other bit blew away, hang on. better. Oops. I've left my solder stuck to it. There we go. Okay. Now, we can stick the rest of the hex nuts on, so I'm not going to be taking the front panel off anytime soon. Unless, of course, I'm going to go back to desolder a load of flipping resistors, which is always possible. Good. Looking smart. Suspicious absence of chips. So now insert the ICs into their dip sockets. We've got this one, and we've got this other one. I'll give this other one a little squeeze in my wonderful IC squeezing tool to ensure that the legs are where they need to be, to make it easier to put in. You can also do the same thing just by rocking it gently against the table. Now these are the same again, so all you've got to make sure is that the orientation is right. You see that little nick there, which corresponds to the silkscreen nick. That's got to correspond to the dot on the front of your chip. So this goes in this way round. Push it in nice and firmly. This one goes the opposite way round, pointing in, because that's where the nick is. Squash it in. Nice. Congratulations! Haha! We have completed the assembly of the module. Now connect it to your power supply, switch it on, it'll be fine. That's what they're saying. If there's no magic smoke, it's a good sign it was successful. Is there something going to be to do with these two trimmers in a minute? Connect a VCO saw output to VCA in 1 and VCA out to a mixer. Rotate the offset all the way clockwise and check if you can hear it. Cool. So I'm going to turn the soldering iron off for the minute. And the fan. Move these things out of the way. Not going to burn anything. Get out of it. Bring back up my little bit of modular. Need my cable. Let's bring this back up a little bit so we can see a little bit more. So for the cable's got a key in it, which is going to go in the slot there. So it's going to go like so. and then this plugs into the power supply on whatever it is you're plugging the thing into. So bring this in. It's going to be at a funny angle. We can cope with that, can't we? Oh yeah, let's just see what we can. So I've got a spare bit of cable here. So in this particular power supply, I've just got floating bus cables attached to a Bafako power supply power skiff. Now I could just assume it's going to work and screw the thing in. For which I'll need the odd knurly. Take one out of there, yeah. Let's borrow that one just for the minute. Borrow that one. Let's shuffle this along because of the glory of sliding rails, sliding nuts, is that you can attach it and then position it wherever you want it to be. Look at that, looks beautiful next to the VCO. Power was here. So now we're going to turn it on, and with a bit of luck it's not going to go boom. Ready? I'm not seeing any smoke. It's a good sign. Really like LEDs though. LEDs are definitely my favourite thing to enable me to see whether something's actually powered or not. So I had a couple of cables. Where did they go? Over here. I could get like a light up cable. Would that be more exciting for the modulation? Look at that. So anyway, that's just a little bit of extra excitement for you there. So we're going to take output of the oscillator, sawtooth. I'm just going to plug that into the mixer. Let's see if we can hear it. Can you hear that? No, me neither. So what haven't I done? Oh, I haven't plugged it in. Here we go. A bit of this into there. Okay, so that's direct, yeah? So now if I plug that into input 1, I should be able to take the output, plug that in to the output. Naff all. No, I've turned it down. God, don't do that to myself. Right, so I've got something happening there. Let's try the bottom side. Yeah. See, I can definitely feel the lack of tolerance down here. How it's all over the place. Do you hear that? See? That's all over the place compared to this, which is like sweetness. Do you get that? No, I'm just joking. I'm just joking. I can't hear any difference at all. So the next thing to do is to then plug in some kind of oscillation, right, into the CV input and see whether that does anything. We're talking. So let's plug this into the bottom end. That's working as well. would call that a success. Now I can also plug into there and get two outputs. Output from there. Output from there. The normalization is working also. Get another one of those, because that's quite fun. Packing it in. Well, I seem to have stuffed every hole, and that seems to be doing what one would expect, and that's awesome. That's pretty awesome. Oh no. It says we need to proceed to the calibrating bit, so that's exciting. As described in the eliminating transistor mismatch section above. I don't know if I can worry about that just yet. Soldering appendix. Okay. So what it wants me to do is eliminate transistor mismatch. Core, geez. Right. I think because we're hitting about 3 hours, I don't think that's what we're going to do. Don't think that's what we're going to do. So there we have it. I think that's probably enough. Except for the hole in the middle. Yeah. We don't talk about the hole in the middle. Yeah, go and have a rest before calibration. So what I think he's saying is that all the way back somewhere else, we did something with eliminating the trimmer. We had a trimmer boosting the signal. No, that wasn't it. Eliminating transistor mismatch. Okay. I mean, that's going to require us to fiddle about with an oscilloscope and bits and pieces. So that doesn't make me enormously happy. It's something one has to do, and I think that's the sort of thing that perhaps you can go and do in your own time. I think if we've got to this point, that's awesome. If it works, that's awesome. Having a little bit of transistor mismatch is not the end of the world in my book. If it's actually controlling volume up and down, then I think that's amazing, and you should be feeling very happy with yourself over that. And the calibration in that regard can be something you can do at in your own time, in your own leisure. So there we go. A celebratory beer is in order. Yes, I think so. If I can get out of here in the next 5 minutes, I think that'll be a good one. So there we go. That is the Dual VCA from Erica Synths and Moritz Klein. It's part of their educational series, and I hope that in soldering this together, that's been helpful if you're undergoing this journey. I appreciate that it's a long haul because I'm doing everything in real time. There's no time lapsing or skipping ahead. We just have to get through it. And 3 hours to solder together a project like this, particularly if you're new at it, is probably about right. I mean, obviously I've talked long and hard about lots of things, and I've been running on and getting distracted and bits and pieces. So perhaps you'll be able to do it quicker than that, a couple of hours maybe. But suffice to say, we got there. It's interesting, the vertical resistor thing is, I didn't particularly enjoy that as it goes. I mean, I understand it as a method of installing resistors in order to save space on the PCB. Yes, absolutely works. But it takes longer to solder. It's more of a faff, and quite remarkably so. Yeah, Marco, you can see the video later on. Yes, either it should hang around on Facebook where you are, or you can see it on YouTube. Either way, it should still be here. Thanks, Tom. That's very nice of you. So, any other thoughts? I mean, I am slightly annoyed about the whole M factor with the resistors. That just needs that little bit of clarity in the documentation. And I think perhaps the best way to do that is for just to have a table of tolerances, the color and the tolerances, and say what you want to do is find the ones, that set of resistors that have this one on it. Those are the ones that you're going to want to use as the M version. Otherwise, it just gets confusing and then frustrating, and then you get a bit kind of annoyed about it. And you don't want to be doing that, do you? You just want that little bit more information, because they're not... I mean, when we were doing the breadboarding yesterday, when I emptied the resistors and looked at them, I knew the number of resistors now because we had the bill of materials, which was helpful. But the fact that they were two different types, I had no idea why. Then there was no point at that point of the manual to tell me why there were two different types of the same resistor. So perhaps it would have been helpful to have a little bit more information at that point to tell you which ones were the lower, higher tolerance ones. I don't know. Do you know what I'm saying, right? That probably would have been helpful. So there you are. That's pointed out something which hopefully should help further people. In the meantime, we're going to be moving on next. Hang on. I can show you what we're moving on next to. Oh, because this has now been announced on the Erica Synths website, I can give you a quick sneak preview of it. Which is this, the case. Now it's just a piece of metal that's been bent into shape, and here these are all pre-drilled holes for putting the modules in. So it's not a case for anything. It doesn't have sliding nuts or threaded rails. It just has these particular holes which fit exactly the modules from this range of stuff to build our complete, awesomely educational synthesizer. That's what we're after. And this is what we're going to be doing next. These are going to be available by the end of the month, about the 24th of February. They reckon they're going to be shipping. They're 110 euros ex VAT, I think, for the case, and that includes the PSU, which is in this box here, which is not too intense. I've never built a power supply before, but it's mostly just putting these sockets on to the board, so that shouldn't be a problem. We're not dealing with mains voltage. It's just going to take 12 volts, and your mains is going to be dealt with in the DC adapter. There is a little bit of shenanigans involved in putting the switch in and the power socket with a little bit of wire. I wonder if that's included in here or not. You might have to go and strip something off an old light. Something. I don't know. I did have a glance at the manual. We shall see. So those are, say, they're available in a week or so. So there's no point me doing this video until people have them in hand. So I'll be looking at doing this probably in the first week of March. So that'll give us a rest of a couple of weeks. And then we can get together and build the case, which is brilliant. And then the rest of it's going to go into that. And we'll start really working towards the completion of this system. Yeah, I mean, I spoke to just in response to putting the resistors into well-labeled bags would be the way to go. I spoke to Gertz at Erica Synths about this whole building kits thing, and they're very keen to push you into working things out rather than spelling it all out. And that's a balance, trying to find that balance between making it easy enough so you don't get frustrated, but also making it challenging enough so that you're having to do a bit of thinking and a little bit of working yourself. And I think one of Gertz's points was that if everything is labelled and everything is written down, then you're just assembling a Lego set. You're just putting something together with no knowledge of what anything does or why it's there. But, I mean, Moritz's documentation and taking it through onto the breadboard is really what hammers all that home. And ultimately, not labelling the resistors just becomes a bit of a point of frustration rather than a point of learning. However, it does force us to measure the resistors and to get familiar with doing that. And so that's no bad thing. That's no bad thing as well. A pre-drilled case is cheating. Sure, yeah. But, you know, this isn't a carpentry course. You know, I've done videos on building a cardboard case with Eurorack. You can go and check that out. So I think having a smart little case like this is nice. I think that's nice. And the fact that the power supply is internal is awesome, and it's going to end up being quite a sweet little thing. There's no reason why you couldn't use this for other Eurorack modules. It's just that you don't have all the holes, so it just has to fit in whether it fits. So cool, nice, there we go. So that's a little preview of the next one, which will be in a couple of weeks. Obviously I will let you all know when that happens, and it shouldn't be anywhere near as long as this one because the manual's much shorter, but it may be that because it's not been done to the same extent. Who knows? We don't know. We're just going to get into it. We're talking about power supplies. How hard could it be? Yeah, right. Good. So that's us, I think. I think that'll do. I'll call that a night. Thanks very much for spending some time with me. It just tickles me pink that you that you spend some time watching this go on. But also, if you are trying to do this and you find this helpful, let me know. It's really helpful for me to know that this is helpful to you. So do say in the comments whether it's something you want me to keep on doing, because I am going to keep on doing it because it's good for me as well as anything else. So there you go. This has been Molten Modular. This has been the Dual VCA. Good night, and in the meantime, go and make some tunes. Hit the outro. Someone hit the outro button.